everyone, I'm Won Lee. We are studying testing hypothesis now. There are three topics: null hypothesis H0 and alternative hypothesis H1. And secondly, there exists only one test statistics and rejection region of H0. Okay, and third, there is significance level, say alpha. Okay, today's topic is how about H0 mu equal to mu 0 versus H1 is mu is not equal to mu 0. It is a basic problem in test hypothesis. Since you understand this one, then you will understand for other parameters. So it is important. Okay, for population mean mu, I say two-tailed test. This is also basic one in order to understand hypothesis test easily. Let us perform a two-tailed test for population mean mu. For example, I take this example. Suppose we want to test the hypothesis. Is the average weight of the potatoes buried in the field before harvest? Average weight of potatoes is 60 gram, just one potato average. In this case, the test statistic is the sample mean x bar because we want to test about average, right? Obtained from sample of n potatoes. So we want to take n potatoes as a sample, and hypotheses are as follows. H0 is mu is equal to 60. Equality should be in H0, null hypothesis, versus H1, mu is not equal to 60. Okay? If H0 is true, correct. If mu is equal to 60, okay, the distribution of a sample mean x bar is given by x bar has normal distribution with mean 60, standard error sigma over square root n, okay, or variance sigma square over n, right? And if we standardize x bar, we get g equal to x bar minus 60 over sigma over square root n as normal distribution with the mean 0, variance 1, right? If H0 is true means we take 60 value of 60 is its mean, so here 60 included. Notice that hypothesis testing is always conducted under the assumption that H0 is true. H0 is true. Under that assumption, we have some procedure for testing hypothesis. However, since we do not know the population standard deviation, sigma, we do not know that, we need to estimate the sigma using the sample standard deviation S obtained from the sample of n potatoes. As stated earlier, where in confidence interval, substituting S for sigma makes G becomes new random variable T, like this, okay? This sigma replaced by S, sample standard deviation S. Then it will have very complicated distribution, say T distribution with degrees of freedom n-1. We already studied that, right? So we use T distribution here for test hypothesis because we do not know sigma. Okay, let's obtain the rejection region for null hypothesis H0. Okay, how to obtain the rejection region for H0 concerning mu at the significance level alpha, two-tailed test. That is a two-tailed test, right? What is mu 0? Mu 0 denotes a given value, say 60. Okay? Whenever you see some 0, mu 0, p 0, sigma 0, then it is given value, some value. Since the significance level alpha is what? How to define this one? H0 true given. H0 is true given that H0 reject. Even though H0 is true, we reject H0. That's probability. Okay? So what is H0 true? Mu equal to mu 0. And the probability of H0 reject given mu equal to mu 0. Then what is it? 1 minus alpha. 1 minus alpha is, this one is fixed here, and H0 accept. And what is 1 minus alpha in confidence interval? We had some steps for that, like this. If we apply the same process as which calculating the 1 minus alpha 100% confidence interval for mu in related to the equation above here, 1 minus alpha, t is greater than probability of t greater than minus t alpha over 2 plus t alpha over 2, given mu equal to mu 0 here, right? You remember this equation? But here in testing hypothesis, we have to assume H0 is true. That is mu equal to mu 0. So just change a letter here. Then same process. Then t is going to be is this value, and we just want to left x bar in center. Then we get this kind of a thing result. Therefore, what? Alpha is what? Alpha is 1 minus, since 1 minus alpha is like this, so alpha is the other areas. All right, here, x bar, some value, mu 0 here, some value here, this one, this part, this value is up here. So this is 1 minus alpha. Then what is alpha? The rest area of this part. So alpha is probability x bar less than mu 0 minus t alpha over 2 s times s divided by square root of n. Okay, here minus, here plus. So this means in the case of two-tailed testing for mean mu, rejection region for H0 is obtained like this. This one is rejection region. Okay, x bar less than mu 0 minus t alpha over 2 times s over square root of n, or greater than, x bar greater than here and here, mu 0, this value is here. Equivalently, the same equations, move mu 0 to the left hand and divide by s over square root of n, then this value from this equation. So minus t alpha over 2 here, and the same thing here. So actually it is the range of rejection region, okay? Rejection region for H0. Same thing, same equation. Okay, I add one more comment today. When starting hypothesis testing under assumption that H0 is true, I told you several times already, it becomes difficult to easily reject H0, which is why the process of hypothesis testing is said to be conservative in accepting new claim H1. Okay, there is a new claim. The contents of H1 is new claim, but we do not want to accept new claim easily. In other words, we do not want to reject H0 easily. Okay, so the process of hypothesis testing is said to be conservative. Okay, it is maybe interesting comment. I hope you understand what I mean. All right, if you don't like equations, but you may understand this rejection region, how to get rejection region under the significance level, alpha. Okay? Okay, that's it today. Thank you. Bye.